Hey, let us look into our next topic, programmable array logic. Programmable array logic is otherwise called as PAL, and it is most commonly used PAL device in PLDs. So you know PLD, programmable logic device, is of two types, SPLD and CPLD. This is simple PLD, this is complex PLD. Simple PLD is again divided into four types. One is PROM, other one is PLA, other one is PAL, other one is JL. In the previous video, we have seen about PROM and PLA. Now we are going to see about PAL. Before saying about PAL, let us understand the difference between PROM, PLA and PAL. If you see this in PROM, for all the three, whether it is PROM or PAL, PLA, there are set of inputs given, and to that particular inputs there are set of outputs we get. Okay, PROM has two stages. First stage is fixed AND array. Next stage is programmable OR. Whereas in PAL you have programmable and fixed OR. It is completely reversed to it. Can you see here the AND is fixed AND, programmable is OR. Here AND is programmable, fixed is OR. Okay, whereas PLA is programmable, both AND OR, both are programmable. So now we are going to see about PAL. Our interest is only on PAL, where if I give an input that is going to a programmable AND followed by fixed OR, right? Let us see it. So now we are going to design a PAL circuit for the given function x, y and z. They have given the functions. Now they want us to design what? PAL circuit. Okay. So what is the first step? Step 1 is minimize the given function. Minimize the given function using what? K-map. So what is the function here? X, Y, Z. So I've taken the first function x of a, comma b, comma c is equal to what? 2, 3, 5, 7. 2, 3, 5, 7. Since it is three variables, I've taken a three variable k-map. I have marked it in the position, in the cells of 2, 3, 5, 7. 2, 3, 5, 7. I have marked once. Now I try to group it. Can you see? These two are neighbors, so I have grouped it. These two are again a neighbor, so I have grouped it. So this forms group 1 and this forms group 2. What is common for group 1? For this pair, what is common? See horizontally, A bar is common for these two cells. What is common for these two cells? BC, BC bar. So B is common in vertical. So it is A bar, B. Okay, for 1. Now let us write for 2. What is common for these two? Horizontally, if you see what is common for these two cells, A. Vertically, what is common for these two cells? B bar C, BC. What is common? C is common. So it is A, C. Right? Answer is A bar B plus AC. So I have obtained the minimal function for the X. Now I am trying to do it for Y. What is Y? Y is 0, 1, 5. In the place of 0, in the place of 1 and in the place of 5, mark once. Okay, then start grouping. So these two are adjacent, so this will form a pair. These two are adjacent, so this will form a pair. Okay, for this pair, what is common? These two belong to A bar. Okay, what is common vertically? B bar, C bar, B bar, C. What is common vertically? B bar. So A bar and B bar is common. Now do it for second group. Second group belongs to this one. Okay, what is common here? For both ones, what is common? B bar, C. So B bar, C. So this is the answer for the second Y midterm. Now do it for the third one. Third one, if you see 0, 2, 3, 5. So in the place of 0, in the place of 2, 3 and 5 are marked all ones. Now I need to do the grouping. So first thing, this corner 1 and this corner 1 can be grouped. This is my first group. This one and this one are neighbors, so I can group. This is my second group. This one cannot be grouped with any of the ones, so I am making it as individual. So what is common in the first group? How will I write the answer for the first group? Horizontally, both belong to A bar. So I write A bar. Vertically, what is common? B bar, C bar. B C bar. So C bar is common. So A bar and C bar is common for 1. What is common for 2? Both the cells belong to A bar. And can you see vertically BC? BC bar. So B is common. So it is A bar B. Now this is all alone. So what is the answer? A, B bar, C. A, B bar, C. So I've got 3 terms. Clear? So now what is the first step? First step is minimize the given function and write the minimal function. Okay. What is the second step? Now I've written the function. I've written the minimal function for x, minimal function for y, and minimal function for z, which we have identified here. Okay. Now let us start working. Now I need to understand number of input buffer. Number of input buffer is equal to number of input variables. How many input variables are there? A, B, C. So I need to use 3 input buffers. This is a symbol for input buffer. This is A and this is A bar. B, B bar, C, C bar. In some books they have directly taken like this. This is A and this is A bar. Either you can draw like this or you can avoid this and draw as a single buffer unit where this will be A and this will be A bar. Okay. So first step we have identified number of input buffers. So what is the number of input buffers? Number of input buffers is equal to number of input variables A, B, C. So there are 3 buffers A, B and C. Now let us see the next thing. Find the number of programmable AND gates. Now see, X has how many minterms? 2. Y has how many minterms? 2. Whereas Z has how many minterms? 1, 2 and 3. So number of programmable AND gates is equal to maximum number of minterms. What is maximum number of minterms? 3. So for each function we need to have how many gates? 3 gates. Is it clear? Number of AND gates is equal to maximum number of minterms. Can you see? X has 2 minterms. Y has 2 minterms, whereas Z has 3 minterms, 1, 2 and 3. So number of AND gates must be equal to maximum number of minterms. So number of AND gates is equal to 3. So I have taken 3 input buffers A, B and C. For each function X has 3 gates, AND gates 1, 2, 3. Y has 3 AND gates 1, 2, 3. Z has 3 AND gates 1, 2, 3. Clear? Because maximum number of minterms is 3. We have to consider 3 AND gates for each function X, Y and Z. Now let us do the OR gate. How many functions are there? See the functions. There are 3 functions X, Y and Z. So you have to use 3 OR gates. X, Y and Z. Now let us see the final implementation. We know what is X? What is X? A bar B plus AC. This is A bar. This is B. Goes to the first gate. It is A bar B. Next is AC. This is A. This is C. Next is AC. Do we have third AND gate here? No. So there is no function. Now come to Y. Y has A bar, B bar, A bar, B bar. It has B bar, C. It has B bar, C. It has third term? No. But we have third AND gate because every function should have 3 gates as per the rule. Third gate is empty. So I have drawn as such. Now what is the third one? A bar B. In the place of A bar, give a cross mark. In the place of B, give a cross mark. A bar C. In the place of A bar, give a cross mark. In the place of C, give a cross mark. What is the third one? A, B bar, C. A, B bar, C. So my AND terms are filled. So you call this as programmable AND. So I can program it. Okay. Now fixed OR. What do you mean by fixed OR? X. This is my first X term. Next is Y term. Third one is Z term. X will get input from first 3. This is fixed. Y will get input from next 3. It is fixed. Z will get input from next 3. Clear? So what is X? A bar B plus AC plus no output. So what will be the output of X here? A bar B plus AC. This is A bar B bar plus B bar C. Though there is no term, we have to connect it to OR get. What is the third one? 3 terms. So what is fixed here? This one is fixed, which cannot be changed. What is programmed? This part and part is programmed. This is how we need to implement a programmable array logic. Thank you.